Infiltration rates is a big part of any type of permeable system, and they're all tested according to the methodology known as ASTM C1701, commonly referred to as the bucket test. You can take a 5-gallon pail, cut the bottom off of it, and that's your proper diameter. The picture in the upper right-hand corner shows a 12-inch diameter pipe with a little plumber's putty installed around the bottom and around the outside. You then take a 5-gallon pail of water weighing 40 pounds, and you time how long it takes to infiltrate that water into the permeable system. Now, most permeable systems, when they are brand new, typically infiltrate at 100, 200, 500 inches per hour, which is pretty significant. Keep in mind, this is just a test to measure apples to apples in terms of permeable surfaces. We understand that the ground underneath is never going to infiltrate at that level. This is just going to show this is how fast this can infiltrate. Most people around the country view anything less than 8 inches per hour as a failure mechanism or needs maintenance to be completed on. That number comes from a hurricane type event as established on the East Coast. This next video we're going to show you will show all the different nuances of the different permeable systems that are out there.
Exact stormwater management. I do a lot of stormwater BMP installations, maintenance, and testing. I'm here today in Northwest DC, hired by Ernest Meyer to do some testing on porous pavers, porous asphalt, porous concrete, and PaveDrain.
Ernest Meyer is our licensed block manufacturer in the DC area. They also supply the permeable pavers and the pervious concrete on this. Now, Sean is using a diffuser on his test to spread the water out across the whole loading. You can see these pavers were tested in 2014 and everything are installed in 2014 and tested the following spring. One key to this whole test, nobody was allowed to do any maintenance on this. And you can see that that was pretty much what was going on as this water was running down on the pervious concrete as opposed to infiltrating in. Pervious asphalt, again, installed in 2014, tested the following spring. Last and not least is us. Now, we were installed a year ahead of everybody, and much to our chagrin, we were installed underneath a tree canopy with all the debris that was dumped into there. We tried to fight it, but lost.
Today, the porous pavers that we started with, we got 3.2 inches per hour infiltration rate. Then we went to porous concrete. We got 2.4 inches per hour. We went to porous asphalt. We got 3.1 inches per hour, and we're here at the PaveDrain, and we got 1,640 inches per hour infiltration rate. This is all according to ASTM C1701.
Obviously, an independent study that was done on that, infiltration test that was done. Modeling of the PaveDrain system, we are available in HydroCAD that you can actually go in and model this. This is a pond you can model, but it is also a pond you can park on, as this is designed as a parking lot. We also have our own PaveDrain storage and infiltration calculator, which we can readily and easily get to you. info@pavedrain.com, and we will send this out to you. Simple Excel spreadsheet. Everything in blue can be manipulated and changed to dial in your particular project as to what you are doing on that. Other things we can provide for you. AutoCAD on top of AutoCAD. I always say it's a lot easier to edit than it is to create, and we're happy to pass these details along for you. Other things we can provide for you is a lot of engineering tests, performance-based specifications, HS20, HS25 load rating, solar reflectance index testing. If there's a test out there that need to be done, I'm pretty sure we've completed it with PaveDrain in a certain degree all over the country as well. Now, one of the things we want to get into is maintenance, acknowledging that the Achilles heel of green infrastructure has been maintenance, and our massive infiltration is a tremendous start to this. But we have been involved with multiple studies all around the United States. Started off at the University of Louisville, and then also moved down to University of Central Florida. We'll kind of go through all of these and really show you what's been going on. So the very first test we were involved with was with the University of Louisville, and it was an assessment of infiltration performance and maintenance of PaveDrain. It started out as a permeable paving or permeable pavement study, and everything else plugged and clogged so fast it turned into a PaveDrain study, which we were very, very pleased about. From there, we moved down to Florida, and they did a whole nother test and documentation at the University of Central Florida, where they really beat you up in terms of maintenance, and we'll show you what they did to this. And that photo and that circled will show you this. So they actually installed the PaveDrain, and then they took a bucket of dirt, topsoil, weeds, you name it, and dumped it right on top of the PaveDrain system. And if that wasn't enough, they ended up hosing it into the open joints of the PaveDrain system. And then what they did is they let it cook, let it bake in the hot Florida sun, and then said, come back and clean it. There's a lot of maintenance, a lot of owners out there that let their properties get to this type of maintenance requirements, but we can bring it back. We hooked it up to our PaveDrain, hooked our PaveDrain vac head up to a combination sewer vac truck, and we were able to bring this back to 90% of its original infiltration rate. Most other permeable systems that are out there, if they're clogged to this level, you have a very challenging time to bring them back to any type of infiltration at all. And PaveDrain, we've proven out time again, you can let it go quite some time and it'll still be able to be brought back and infiltrate properly. So after that became a pollutant removal project with the University of Louisville. And finally, the EPA came out with one of their studies, and these studies are still going on today. And the last test that we want to focus on or talk about is the Tetra Tech test that was done for the city of Detroit. It's another whole maintenance study. How far can you let it be clogged before you can bring it back? And they found out the same things that they found out in Central Florida. You let it go a long time and it'll still bring it back. The type of documentation and the type of projects that we're really getting into across the country is the picture that's circled in the on the right hand side of your screen, where we have gray infrastructure, i.e. the inlet, combined with green infrastructure, i.e. the PaveDrain. And this is what is helping the hydrograph within these municipalities flow a little bit better. So this project controlled 19H and 19G. A lot of the permeable systems out there and a lot of the codes and regulations all talk about not allowing anything more than a 1-to-1 or a 5-to-1 run-on, meaning 5 square foot of traditional impervious surfaces, concrete, asphalt, roofs, running onto 1 square foot of a permeable surface. This study really cranked that up 16-to-1 and 20-to-1, as you can see there. And why they had that set so low is because of debris. Not wanting that amount of debris to get into that and plug these systems very fast. We ended up getting this up to 20-to-1. Now, we know full well that there's going to be a tremendous amount of debris that gets into this. So how does an owner cost effectively maintain this? So this is what 19G and 19H look like. There's a 10-foot cross section in here, all lined with the geotextile. Up at the top, there's about a 3-inch layer of 57 stone. You'll see a little black line on top of that, the bigger stone there. They put a geogrid in there. And again, it was about an 8-foot width. They put in piezometers into this to document how much storage and how much volume was being captured in this, which gave us some ideas for later application for this. But it was a true electronic measurement. And both of these structures, 19G and 19H, confirmed that we were getting 100% of the runoff, or a 1-to-1 ratio. The problem is, the first 10 months, it didn't rain. We only got about 40,000 gallons that happened. Now, the last 2 months, it did nothing but rain, and we more than made up for that. So keep that 40,000 gallons in mind for this as we started off doing this. Clogging and maintenance, we know it is going to occur. There's a way to do some visual inspections. Unlike most other permeable systems, PaveDrain can actually tell you when it needs to be maintained. You can drive over it, walk over the top of it. The joints are completely plugged like you see in this picture. Probably time for some maintenance. You got a little problem with this going along, but we'll show you what we've come up with to help solve this for owners, so this is less subjective that is out there. Because even though we had projects that looked like this and they would get heavily, heavily rained on, they still wouldn't puddle. So how do you really know when they need to get maintained? And we'll talk about that here in a little bit. We tried different things. We really did not know exactly how to maintain this. So the first thing we tried was a vacuum truck. You'll notice the quotes. What we later found out was this was a crosswind, an Elgin crosswind, otherwise known as regenerative air. And this is really nothing more than a great big leaf sucker. And it just didn't have enough oomph to pull up the debris within the joints of the PaveDrain block. But we were told it was a vacuum truck. From there, we went to compressed air and water, where we blew out the joints of the PaveDrain. It kind of worked, but it really didn't, because as much as debris as we pushed out, it was also getting shoved back down into the open aggregate section. And you can see in the bottom of the photo, it was also blowing it down out of the joints. And as soon as it rained, it washed it right back in. So we really didn't accomplish anything by that. And what we ended up doing was the city said, you guys are close, but you got to vacuum it out. So we worked with another supplier, and we created the PaveDrain vac head that can get hooked up to a combination sewer vac truck. And this vac head worked spectacularly. It really solved our problem. It vac stuff out. But like anything, there's some nuances and things that we had to do. The results on this were really quite amazing for us. Hopefully this video will start. Like anything, when you're testing it, you make some mistakes. So the very first mistake we made on this was we made the wheels way too small, and we had to rectify that. So this was our very first run that we did, and this is back at Ford Motor Company. And so again, they hadn't done a whole lot of maintenance out there, so they were giving us free rein to go out there and do some testing on this. And as they're going along here, you'll see what is going on underneath there. Nick will pick up this this PaveDrain vac head and flip it up and show you what's going on. The water source for this is coming from the combination sewer vac truck, and about 1,000 PSI is being pumped out of that circular head. This vac head really doesn't work on anything else. Permeable pavers, it really struggles with that because all the rocks and debris damages the wands. Pervious concrete and asphalt, it does okay, but it tends to damage them just from the amount of pressure on that water. But you can see from this that it is sucked out everything, including that little weed and the cigarette butts, which are pretty common out there. This is the maintenance effectiveness of doing this. The dashed line on there represents the average baseline infiltration rate, which was established by the University of Louisville at 1,250 inches per hour. They determined that anything that was above that was just kind of crazy. But you can see by the green lines in the post-vac head test that we got those green lines way up over that, even after air jetting and all the other stuff that we did, the mistakes we made to this. We still were able to get it back to flowing brand new. The conclusions, the red line here will represent the cumulative surface runoff. The black line represents what was captured. Now, if you remember from a few slides earlier, it didn't rain a whole lot the first 10 months. The last 2 months, all it did was rain, and in a very small area, 1,500 square foot, we captured 250,000 gallons of water across, like I said, 1,500 square foot. Now, when you start looking at this on a citywide scale, and you start putting in 1,000, 1,200, 1,500 square foot of PaveDrain, upgrading of every inlet in the city, you can drastically reduce the hydrograph that is affecting these these flood-prone areas within these cities. The next thing that started happening was these municipalities started coming to us saying, we just don't like having our laborers or our workers outside of these trucks. We need something that's mechanical. So we went back to the vacuum trucks, and we actually found what is called a pure vacuum truck. This particular brand is an Elgin Whirlwind or Mega Wind type of truck. That's a port down there that is only about 2 inches wide and about 18 inches long. Tremendous amount of suction. You can see a little bit of water being sprayed on top of this debris to suck that up. A lot of organics in this. This thing will actually move the blocks around. There's so much suction coming up out of there. You can kind of hear them chinking and banging around. There's so much suction coming up out of that. That truck's only going along at about 2 to 3 miles an hour. Then what we always have to do is what we call the gratuitous water dump test, just to show that we are back to infiltrating as it was, as if it was brand new. This slide shows the first pass going down Washington Street back in Louisville, what it looked like kind of before and an after shot. We even did a tape measure and went down the full depth of that to show that we had cleaned all the way down to the rock base. That's an organic street type application. What we wanted to do is go back out to Ford and do that had a little less organics. Now this is a Google Earth shot showing the pave drain outlined in yellow. This is all of the asphalt areas drained to this, to the pave drain there. This is a staggering amount of debris, a lot of mud, dirt, grit, grime, you name it was on top of this. And again, Ford had never maintained this. We're showing the Elgin whirlwind there. And just to give you a scale, we threw a set of keys down just to show you how much dirt and sedimentation had been accumulated on the pave drain in about, let's call it a 6 to 7 year period at this point in time. The picture on the left is showing prior to cleaning and just how impacted this was with dirt and debris. The first pass was over the top of that on the lower right-hand corner. Then we go inside of that, and you can see what it looks like inside of this tank. And one of the questions we like to ask during our presentations is what's missing inside this holding tank if permeable pavers would have been installed. And the correct answer to this is all the rock, which you would now have to go out and repurchase, rebuy, and reinstall into that. Vacuuming it out is the easy part. Rebuying the rock, putting it back in is what is expensive with that. It also increases your dumping cost because of the sheer weight with all that rock being inside of it. With this, it's just obviously a lot of grit, grime, and small debris. Maintenance effectiveness and conclusions. Performance can be restored. The type of maintenance is important. It's got to be vacuumed. When to maintain is becoming the next step. And also, how much stormwater are we capturing? You know, there's been a lot of green infrastructure that's been designed over the years, and I'm sure a lot of us have really no idea exactly what's been going on and how much stormwater we've been capturing. We've tracked a few jobs within the 3.5 million square feet of pave drain we've installed around the country, and on just a small smattering of jobs, the amount of gallons we've captured is kind of staggering. But we wanted to be a little more definitive on that. So a few years ago, we started working with P4 Infrastructure and their owner, Chris Foley, to dial this in. And at this point in time, I'm going to turn this over to Chris Foley.